Welcome to Jeremy's IT Lab. This is a complete course for the CCNP ENCOR Enterprise Core exam. In this video, we'll look at the basics of MSTP, Multiple Spanning Tree Protocol, which uses RSTP's underlying mechanics, but provides greater efficiency in LANs with many VLANs. Here's what we'll cover in this video. First, I'll introduce the need for MSTP, why and when it should be used, and the advantages it offers. Then, we'll look at basic MSTP configuration. In the process, we'll cover the basic mechanics of MSTP. Before getting started, here's a brief summary. Multiple Spanning Tree Protocol, MSTP, or often just called MST, allows you to map multiple VLANs to a single spanning tree instance. And why would you want to do that? It greatly reduces the number of BPDUs that need to be sent, and the amount of processing that switches need to do in a LAN with many VLANs. This is in contrast to rapid-pvst+, which runs a unique spanning tree instance for every single VLAN. MSTP uses RSTP's underlying mechanics for rapid convergence. All of the concepts we covered in the previous few videos apply to MSTP. Note that this video focuses on the basics of MSTP. MSTP within a single MST region. We will cover more advanced topics, such as LANs with multiple MST regions, in another video. Let's get started by looking at why MSTP is beneficial. We'll do that by looking at a downside of rapid-pvst+. Rapid-pvst+ allows for load balancing among switches in a LAN by assigning a different root bridge for each VLAN. For example, in a LAN with 100 VLANs, each distribution layer switch can be the root bridge for 50 VLANs. So in our example on the left, let's say switch 1 and switch 2 are distribution switches, and switch 3 is an access switch. Of course, in most cases, there will be more than one access switch, but for demonstration purposes, there's no need to show others. They will all be connected to the distribution switches in the same pattern as this, forming a triangle. So if this LAN uses VLANs 1 to 100, we could assign switch 1 as the root bridge for VLANs 1 to 50, like this. And switch 2 could be the root bridge for VLANs 51 to 100, the second half of the VLANs. Note that these assignments should align with the HSRP or VRRP, active or master routers. In most cases, the distribution switches will be multi-layer switches, and they should use a first-hop redundancy protocol on their SVIs to provide a redundant default gateway. So if switch 1 is the root bridge for VLANs 1 to 50, its SVIs should be the HSRP active or VRRP master for those VLANs. So access layer switches, such as switch 3, will forward frames in half of the VLANs to one distribution switch, and frames in the other half of the VLANs to the other distribution switch. This shares the traffic load among the links, making use of the available bandwidth in the LAN. So what's the problem? The problem is that each rapid-pvst+ instance runs independently and sends its own BPDU every 2 seconds. In our example LAN here with 100 VLANs, that means 100 BPDUs are being sent on each link every 2 seconds. Sending, receiving, and processing these BPDUs uses resources on the switches, as well as bandwidth in the LAN. The thing is, in most cases, only 2 unique spanning trees are needed. One with one distribution switch as the root, and one with the other as the root. That's the case in this example LAN here. 50 of the VLANs use switch 1 as the root, and the other 50 use switch 2 as the root. There's no need to have 100 different rapid-pvst+ instances running, and taking up resources for only 2 different spanning trees. So what's the solution? Of course, it's MSTP. MSTP allows for multiple VLANs to be grouped into a single MST instance, called an MSTI, requiring only 2 instances to achieve the same load balancing. Notice that up top, VLANs 1 to 50 are grouped into MSTI1. Similarly, VLANs 51 to 100 are grouped into MSTI2. This reduces the resources used by spanning tree protocol, while providing the load balancing and rapid convergence of rapid-pvst+. So in a LAN with many VLANs, you should consider using MSTP instead of rapid-pvst+. There is no agreed-upon threshold for the number of VLANs, But in a LAN with 100 VLANs like this, it's probably a good idea to consider using MSTP instead of rapid-pvst+ to reduce the burden on the network. In this diagram, I show two MSTIs, MSTI1 and MSTI2. In reality, there is also a third one operating in the background, MSTI0. Let's move on to look at MSTP configuration and cover some more details of how MSTP works, including the role of MSTI0. Here are those three switches. To see how MSTP works with its default settings, let's use spanning tree mode MST to enable it on these switches. Modern Cisco switches run rapid-pvst+ by default, so you need to use this command to enable MSTP. Then on switch 1, I used show spanning tree MST to view the default settings. First, take a look at this line here. MST0, VLANs mapped 1 to 4094. All VLANs are assigned to MST instance 0 by default. This instance plays a special role in MSTP. MST instance 0, or MSTI0, is called the internal spanning tree, the IST. Its significance will become clear in the next lecture video, so I won't go into the details here. Just keep in mind that it can't be disabled, and it is not recommended to use MSTI0 for active VLANs. All VLANs are assigned to MSTI0 by default, so we'll assign the active VLANs, which are VLANs 1 to 100 in this case, to other MST instances later. But for now, let's continue to look at this output. Let's move on to these three lines. The bridge line shows information about this switch. It shows the switch's MAC address and priority. In other words, its bridge ID. At the end of the line, it lists the sys ID. This is the extended system ID. In Cisco's PVST+ and rapid-pvst+, this is the VLAN ID. So in VLAN 1, the VLAN ID of 1 is added to the priority, making it 32768 plus 1, so 32769 by default. In MSTP, on the other hand, the extended system ID is the MST instance ID. This is MST instance 0, so the sys ID is 0. Then, the root line shows the same information for this MST instance's root bridge. The regional root line is this MST region's closest switch to the root bridge of the common and internal spanning tree, the CIST. This video focuses only on the absolute basics of MSTP, so we'll cover MST regions and the CIST in the next lecture video. Don't worry about understanding this definition yet. Finally, look at the port costs here. MSTP always uses the long path costs, and here they are for review. All of the interfaces in these videos will be 1 gigabit per second interfaces, so the port costs will always be 20,000. But you should be familiar with the costs of interfaces of other speeds. Before we assign this LAN's active VLANs to other instances, let's see how to configure the root bridge of MSTI0. I made switch 1 the root bridge with spanning tree MST0, priority 4096, and made switch 2 the backup with spanning tree MST0, priority 8192, to ensure that switch 2 becomes the new root bridge if switch 1 goes down. Just like PVST+ commands require you to specify the VLAN ID, like spanning tree VLAN 1, MSTP commands require you to specify the instance ID, like spanning tree MST0. Next, I used show spanning tree MST on switch 3 to verify the topology. Take a look at its interfaces. G00 is switch 3's root port for this instance, and G01 is an alternate port. So that means the link between switch 3 and switch 2 is effectively disabled, preventing loops. Because all VLANs are assigned to MSTI0, the link is disabled for all VLANs. In some cases, this might actually be desirable. If your LAN only requires a single STP topology, so the same root bridge for all VLANs, you can use MSTP to allow all VLANs to share a single STP instance, which is MST instance 0. And in such a LAN, this is more efficient than running 100 rapid-pvst+ instances. Instead of 100 BPDUs, each designated port only sends 1 BPDU every 2 seconds. In effect, this is similar to IEEE standard rapid-STP. Only a single instance is used for all VLANs. So to summarize, in a simple LAN where you want one switch to be the root bridge for all VLANs, you can use MSTI0 to allow all VLANs to share a single spanning tree instance. This is more efficient than running rapid-pvst+. However, let's take advantage of MSTP by splitting up the active VLANs into two new MST instances. We will assign half of the VLANs, VLANs 1 to 50, to MSTI1, with switch 1 as the root bridge. And we will assign the other half, VLANs 51 to 100, to MSTI2, with switch 2 as the root bridge. First, let's configure the root bridge of each instance. To do so for MSTI1, I'll use the same command as before, spanning tree MST1 priority, followed by the priority value. I made switch 1 the root and switch 2 the backup. And then I did the reverse for MSTI2, with spanning tree MST2 priority, and then the priority values. Next, let's move on to mapping the VLANs to each MST instance. We need to configure the same mappings on switch 3 as well, so let's do that. First, use spanning tree MST configuration to enter MST config mode. From here, use instance 1 VLAN 1 to 50 to assign VLANs 1 to 52 instance 1, and then instance 2 VLAN 51 to 100 to assign the other half of the VLANs to instance 2. Note that the configurations made in MST config mode don't take effect until you exit MST config mode. So, use end or exit to leave MST config mode. Okay, that's all that's required for our simple MSTP configuration. Now let's look at a few MSTP verification commands. Show commands we can use to verify MSTP on the switch. Here, we see the first one, show spanning tree MST configuration. This command shows the settings we just configured in MST configuration mode. For example, the MST configuration name and revision number, which can optionally be configured. We didn't configure them in this case, because this example doesn't require them. But all switches within the same MSTP region must have the same name and revision number. Basically, an MSTP region is a group of switches that share the same MSTP configurations. As I said previously, we will cover MSTP regions in the next lecture video. They are a more advanced topic. Okay, this command also shows the different MSTIs and the VLANs mapped to each. As we just configured, VLANs 1 to 50 are assigned to MSTI1, and VLANs 51 to 100 are assigned to MSTI2. All other VLANs, the ones we aren't using in this LAN, remain assigned to MSTI0, the internal spanning tree. The next command is show spanning tree MST interface, followed by the interface name. At the top of the output, it gives information such as the status of STP toolkit features, like portfast and BPDU guard. We haven't enabled anything, so they are all disabled. And at the bottom of the output, it shows the status of the interface in each instance. In instances 0 and 1, G00 is a root port, but in instance 2, it's an alternate port. Finally, you can also use the same show spanning tree MST command that I showed earlier. Skipping over the output for instance 0, here's instance 1, and here's instance 2. We already saw this command's output when looking at instance 0 earlier in the video, so let's move on. Finally, we'll compare rapid-pvst+ and MSTP configuration commands. We've covered these commands in the previous videos on STP and rapid-STP. So instead of covering how they work again, let's just take a quick look at their MSTP equivalents. First, some commands from global config mode. In PVST+, you can use the spanning tree VLAN root primary or secondary commands, or the spanning tree VLAN priority command to modify the switch's priority for the specified VLAN. The commands are similar in MSTP, but instead of specifying the VLAN, you specify the MST instance. Next, in PVST+, you can configure the hello time, forward time, and max age with these commands. The MSTP equivalents are spanning tree MST hello time, spanning tree MST forward time, and spanning tree MST max age. There's one notable thing to point out here. Notice that you don't have to specify the MST instance in these commands. That's because in MSTP, only the IST, that is MST instance 0, sends BPDUs. So in these commands related to timers, you don't need to specify the instance ID. Next, we'll look at a couple of interface config mode commands. In PVST+, we have spanning tree VLAN cost and spanning tree VLAN port priority to configure the interface's STP cost and priority in the specified VLAN. In MSTP, the commands are similar, but you need to specify the MST instance instead of the VLAN. And one final note. Other PVST+ commands that don't require specifying a VLAN are identical in MSTP. For example, commands used to enable portfast, BPDU guard, BPDU filter, etc. are the same. Spanning tree portfast, spanning tree BPDU guard enable, and spanning tree BPDU filter enable. We'll examine some of these commands in the next lab video, but for now let's review and then go on to the quiz. In this video, we covered why MSTP is useful, as well as basic MSTP configuration in Cisco iOS. To summarize, MSTP, or sometimes just MST, allows you to map multiple VLANs to a single spanning tree instance. This greatly reduces the number of BPDUs that need to be sent, and the amount of processing that switches need to do in a LAN with many VLANs. And MSTP uses RSTP's underlying mechanics for rapid convergence. Finally, here are the main commands we covered in this video. We listed some more in the previous slide, but these are the ones we actually used in this video. Use spanning tree MST, the instance ID, and then priority, and the priority value, to configure the switch's priority for the specified MST instance. Use spanning tree MST configuration to enter MST configuration mode, from which you can use instance, the instance ID, VLAN, and then the VLANs you want to assign to the specified instance. In this video, we assigned VLANs 1 to 50 to instance 1, and VLANs 51 to 100 to instance 2. We also covered a few show commands. Show spanning tree MST lists information for each MST instance, such as the switch's bridge ID, the root bridge, and the status of each interface. Show spanning tree MST configuration shows the settings configured in MST configuration mode. For example, it lists the configured MST instances and which VLANs are mapped to each instance. We also covered Show Spanning Tree MST Interface, which lists the status of the specified interface, such as its STP role in each MST instance. In the next lab video, we'll cover these commands and others. But for now, let's move on to this video's quiz. Here's quiz question 1. You issue the spanning tree mode MST command on a switch. The rest of its STP-related configurations are default. Which of the following statements are true after you issue the command? Select 3. Pause the video now to think about the answers. Okay, the answers are C, E, and F. When you enable MSTP on a switch, all VLANs are mapped to a single MST instance by default, which is MSTI0, also known as the internal spanning tree, or IST. So C is correct. MSTP always uses the STP long path costs, so E is correct. Note that this is true even if you have configured the short path costs with spanning tree path cost method short. That command doesn't take effect when the switch is running MSTP. And MSTP uses RSTP mechanics for rapid convergence, so F is correct. Although MSTP introduces many new concepts, the underlying convergence mechanics are identical to RSTP. Okay, let's move on to quiz question 2. Which of the following is configured in MSTP configuration mode? Pause the video now to think about the answer. Okay, the answer is A, VLAN to MSTI mappings. B and C are configured in global config mode, and D is configured in interface config mode. But A, VLAN to MSTI mappings, are configured in MSTP config mode. You can access MSTP config mode with the command spanning tree mst configuration. Okay, that's all for the quiz and this video. I hope it was helpful. Thanks for watching. Before finishing this video, let me thank my JCNP level channel members who support me through YouTube channel membership. To become a member, please click the join button under the video. Thanks to Jonathan Makura, Velva Jacob, George, Nasir Chowdhury, Gustavo Macedo, Marcel Lord, Dragos Hernea, Zakib Shah, Mayor Salman, Vitaus194, Chance Carter 56, Mark Jackson, Bold 1C1U, Gerald Guillaume, Fristos 1207, Hector Hernandez, Arpad Conives 5 Feet, Owad Daniel Brown, Jose Alvarez, Hussein Yavuz, Samuel Tavares, Kevin Hayes, Roger Bratseth, Brian Grant, Georgi Gemejev, Cats for Life, Adelson Pereira, Farad 69, Madmark 50484, Alexandru Stratan, Lucian Stoichitoiu, Hiago Bicalho, DMJ2, Kurt Nell, Dear Diso, Steve Cox, Jasper Yim, Pedro Hartman, Tricky Mickey 123456, Ivano Capuano, Jefferson Steelflex, Toxic, Wilmer Romero, Sinan Sarisinar, Gio, Daniel Andrade, Mike Crumby, Dragos George, Jairo Francisco, Filip Jovanovic, Wagner Botelho, Mateusz Zashinsky, Ruben Hernandez, Electro Jedi, Trevor Goldman, Gavin Paultek, Sunny Idigu, Jeffrey C., Chitsinde, Stephen White, Edificare, Dragan J., Fio Fiohain, Dimitro Lis, Fares Al-Zaharani, Jean-Marcel Belmont, Mikhail Chapsky, Himanth Jabalpuri, Dariush D., Juan Morales, Doomed Soul, Christine Schubert, Julio Maya, Josi, Prashanth M., Egraso, Komlan Kapedemi, Gurkhan Doimaz, Anand Abyankar, and JFlow99. Sorry if I pronounced your name incorrectly, but thank you so much for your support. Thanks to you and my other supporters, I am able to make these videos and release them for free on YouTube, so I really appreciate the support. Another great way to support the channel is to like the video, leave a comment, subscribe, and most importantly, share this video with others. So if this video was helpful, I'd appreciate it if you did any of those. Thanks for watching.